Okay, so we have question 7. It says Selby decided today that it will save 15,000 per quarter over the next 4 years. He will make the first deposit into a savings account in 3 months' time, and he will make his last deposit at the end of 4 years from now. 7.1.1 says how much will Selby have at the end of 4 years if interest is earned at 8.8% per annum compounded quarterly, right? So now, since we are told that he's saving, we know this is future value, and then the 15,000 here, this is our fixed deposit. So these are the X amounts, right? Then having to tackle 7.1.1, we know we use our future value. Then the fixed deposits are your 15,000. 1 plus the interest is 0.088 over 4 because it's compounded quarterly. Then how many quarters are there in 4 years? So we have to say 4 times 4. That will give us 16. Then all over 0.088 over 4, right? So punching all that in your calculator, you find that the value of the investment or the savings after the 4 years will be 283,972.28. Right. Now 7.1.2 says if Selby decides to withdraw 100,000 from the account at the end of 3 years from now, how much will he have in the account at the end of 4 years from now? So he decides to withdraw the 100,000 before the end of the investment period. So now we know that when you withdraw money from an investment account, there are penalties, right? So when he withdraws this 100,000, he will not only withdraw the 100,000, but he will also withdraw the interest. The 100,000 will be withdrawn with the interest that he could have earned for the remaining year that was left until the end of the investment period. So having to calculate that, we say A is equals to the investment value is 283,972.28 for that 4 years, right? Then minus 100,000 is withdrawing 100,000, so we subtract that. But then the 100,000 will be withdrawn with the interest, so we have to raise that 100,000 or grow that 100,000 using our compound formula. 0.088 over 4. But then remember, interest is earned per quarter, so we have to represent our 1 year in terms of quarter. So that's 1 times 4, that's 4, so we put 4 here, right? Then what will be the money that will be accumulated if now we withdraw that 100,000? So in 4 years, the money that it will accumulate is 174,877.60, right? All because we withdrew that 100,000. Now 7.2 says Tepo takes a home loan, takes out a home loan. So this is a loan over 20 years to buy a house that cost 1,500,000. Now 7.2.1 says calculate the monthly installment if interest is charged at 10.5% per annum compounded monthly, right? Compounded monthly. So here we are not told that Tepo pays a deposit, so we assume that it takes out a home loan of this whole amount, 1,500,000. So loan, we make use of the present value. Then 1 plus I to the square of negative n over I. Right. So we are supposed to calculate our monthly deposits. So we have the value of the loan, that's 1,500,000. And then X, 1 plus the interest, 10.5%, 0.105 over 12. And then how many months? 240. Where do we get this 240? 20 years times 12, that's 240 months. And then all that over 0.105 over 12. So having to calculate the X amount, quickest way, we just cross multiply here, 1,500,000, and then multiply by 0.105 over 12. Then you take all of this and divide. To the exponent of negative 240. And then the value of the monthly installments, that's 14,975.70. Awesome. 7.2.2, we are told to calculate the outstanding balance immediately after the 144th payment was made, right? So for the outstanding balance, we know that we have to make use of the present value formula. So we have P, X, and then 1. So you will remember that the X we've calculated in the previous question, and then we found that the monthly installments will be 14,975.70. Then the interest is still 10.5, so that's 0.105 over 12. But then here, let's come to the number of payments that we need to substitute here. So remember that we started from T0, and then now they're asking if he has made the T144 payment, so the 144 payment. But then remember, the total payments that he has to make is 240. So now to calculate the outstanding balance, remember the outstanding balance is the amount that he has to pay for the remaining period of the loan, right? So how many outstanding balance are there after he has made the 144 payment? So we have to say 240 minus 144, and then we get that his outstanding payments are 96 payments. So this is what we're going to substitute here. So this is negative 96. That indicates that he is only left with 96 payments up until the end of the loan period. Then the I is 0.105 over 12. So now having to punch all this in your calculator, you find that the outstanding balance after the 144 payment has been made is now 969,000, then 927.94, right?